Good afternoon again. Welcome to my math tutorial number 53 part B. My name is Mr. Lobex Cesare Lorengo. The topic today is rates, ratios, proportions, and percentages. In this part, I'm going to handle proportions and percentages. In 53A, I handled the parts involving rates and ratios. A proportion is a way of comparing two ratios. Direct proportion. Two quantities, say A and B, are in direct proportion if an increase in A causes a corresponding increase in B and vice versa. That means a decrease in A causes a decrease in B. A and B increase or decrease in the same ratio. A and B are also said to be directly proportional to each other. Therefore, directly proportional is this. Direct proportion is also implied that it is directly proportional to each other. Example 5, extension of 53 part A. A farmer takes 8 days to cultivate a plot of land, 1.5 acres in area. Determine the area of land he will cultivate in 20 days, working at the same rate. Solution. Number of days increase in the ratio 20 to 8. That's from 80 days to 20 days. That's the new value to the original value. Similarly, the size of land must increase in the same ratio 20 to 8. Therefore, 20 ratio 8 is the same as the unknown area ratio the area that was given 1.5. When we write this one as a fraction, we get 20 all over 8, the same as A all over 3 all over 2, which is 1.5. Now the value of A when cross multiplying will be 20 times 3 all over 2 all over 8. That implies the answer is 3 and 3/3 of land. 3/3 of land. Indirect proportion, also known as inverse proportion. A is inversely proportional to B if an increase in B, even an increase in A causes a corresponding decrease in B, and vice versa. Vice versa means that if A decreases, it causes a corresponding increase in B. When A increases in the ratio M to N, B decreases in the ratio N to M. For example, when the speed of covering a fixed distance is doubled, the time is halved. For example, for a certain amount of money that is fixed, the share per person increases if the number of beneficiaries decrease. Note that for indirect proportion, a quantity must be fixed or constant as illustrated above. We have example 6. In example 6, a mother had enough money to buy 24 bananas at 4 shillings and 50 cents a banana. How many would she buy with the same money if the price of the banana is 50 cents less? In this case, the price of the banana has reduced by 50 cents. Now, as the price has been reduced and the same amount has to be spent on bananas, that implies that the number of bananas bought will increase. Solution. Number of bananas and the price. Number of bananas, when the price is 4 shillings and 50 cents, the mother is able to buy 24 bananas. When the price reduces by 50 cents, it now drops to 4 shillings. We have any bananas which are being bought. Therefore, the ratio of change of these quantities, for the number of bananas, the ratio is N to 24, while the ratio of the price is 4 to 4.5. This implies that N equals to the number of bananas that was already given, 24, times 4.5 all over 5. We have taken this one inverse proportion because for inverse proportion, we change the ratio. If the price has increased, we now decrease the number of bananas. But if the ratio has decreased, the price has decreased, we increase the number of bananas. Therefore, in inverse proportion, we multiply the number that was given there times the inverse of this ratio, 4.5 all over 4. That one worked out, get 27 bananas. That implies that when the price drops from 4 shillings and 50 cents to 4 shillings. The number of bananas increases from 24 to 27. Let's move to percentages. A percentage is a fraction whose denominator is 100. For example, 50% means 50 out of 100. Converting fractions and decimals into percentages. If A over B is a fraction, then its percentage is A over B times 100%. A decimal is expressed as a fraction first before multiplying it by 100%. For example, 0.35 is expressed as 35 over 100 times 100%, which is at 5%. Alternatively, also 3.257 can be expressed as 3,257 over 1,000 times 100%, which is 325.7%. Alternatively, decimals can be converted to percentages by just shifting the decimal point to the right 2 times. For example, 0.35 times 100, the decimal place is shifted twice to get 35%. 3.257 times 100%, the decimal place is shifted twice to give us 25.7%. Now let's move to the next level, percentage increase and percentage decrease of a given quantity. If a quantity Q increases in the percentage P, then the new value of Q is 100 plus P percent of Q. For example, if the price of a kilogram of sugar increased by 20% from 120, then the new price is 120% or 100% times 120 shillings, which is 144 shillings. If Q decreases by P percent, then its new value is 100 minus P percent of Q. For example, if the price of the kilogram of sugar above decreased by 10%, then its new value or its new price is 90, which is 100 minus 10 or over 100% times 120, that's 108 shillings. Example 7. An insurance firm reduced its annual premiums for a policy by 12.5% to 850 shillings. What was the premium amount previously? In this case, you have been given the final value of the premium after the decrease. That implies the premium is 87.5%. Now what about 100%, which was the initial value of the premium? We cross multiply, get 850 times 100% over 87.5%, which gives us 971.428,571, which is approximately 971.40 shillings. We write into decimal places with the second decimal place being a 0. Thank you for watching. I welcome you in advance to my math tutorial number 54, which will involve topical revision of the topic rates, ratios, proportions, and percentages. Thank you for your time.